Hey, I'm Alan Firstenberg,
And I'm Noble Ackerson,
and welcome back to Two Voice Devs.
Two Voice Devs.
Noble, after last week's episode, we just had to keep it going. So for those who really have forgotten the exciting episode last week, you were kind of talking us through generative UI
Mhm.
and explaining why there were some pitfalls, where the pitfalls were. So let's pick it up from there, see some examples of those pitfalls, and then discuss how you are working to work around them, avoid.
All right, Alan, let's break this down again. So, from last week, we were talking about generative UI, which is distinct from creating a user interface with the help of an LLM or that kind of stuff.
Right. So for the past couple of years, when we've been creating a UI using an LLM, we'll kind of ask it to do something, it'll give something back. Maybe there will be this interactive back and forth.
Right. The
Just like we're
development process.
right,
Yeah.
just like we
Yeah.
were building any other code.
Exactly. And that is distinct from what we're talking about. Again, we're talking about a system that dynamically adapts based on my preferences, my search history, or my intent, or my user's intent, in real time or near real time, in a way that sort of persists over time. If that's what your angle is, or if it's maybe a chat window, you can sort of change the interface to fit the need. And the whole concept here, in my opinion, is more comes focused. You always want to sort of look what your end users are trying to accomplish in your application, and the technology should try to further the said user towards that goal as seamless and as quickly or as effectively as possible.
And I think that's important. That's important. I mean, I think it's important in a lot of ways, but it's always important to remember that the objective here isn't to do something cool. The objective here is to make people's lives easier, better, faster, whatever. The technology does not or should not exist just for technology's sake. So I think this is important to understand and remember.
So we'll start this episode with a quote from author C. Clarke. Any advanced technology is indistinguishable from magic. And the way I'm going to recontextualize that quote is to say a lot of what these tools that we've been using to enhance our experiences with the applications and the solutions that we use every day should, to your point, Alan, abstract the tech out of the way and just focus on helping you and helping you achieve your goal.
You've heard Larry Niven's response to Clarke, haven't you?
I'm curious to hear.
Larry Niven responded to Clarke by saying, any sufficiently advanced magic is indistinguishable from technology.
That is funny.
And
That is awesome.
I love those two quotes together.
I love those. So we're here to talk about where we left off last time. I hinted at a solution that I've built to sort of demonstrate generative UI. And if you don't mind, I'm going to sort of share my screen and we're going to sort of jump right into that. Okay?
Sure, let's take a look.
Let's look at this as a smart home dashboard. This is not real data. This dashboard has things like my cameras, my camera feed in the back, and some smart home controls that I have. But because I'm a data nerd, I love data. So I also like to see certain pieces of information around the house, maybe a trend chart, temporal trend chart of how my temperature fluctuates over time based on an API or a tool that my solution uses or a resource that it needs to fetch. Okay. And these types of solutions are pretty cookie cutter. What I've just showed you is a traditional UI. I click, it's deterministic. If I click on a settings page, I get a settings link. And it's also standard user experience, right? Every single one of these is a tool that my LLM is calling, and you can sort of see a debugger here on the right. Just ignore it. It's sort of a local build of the solution. But let's go back to the devices that were using the most electricity. Often, especially in corporate contexts, we have these dashboards, and I don't care about the UI, but I'm forced to use it, and I have to click so many things in order to get to done or to get to value. But in some cases, there might be other um, visualization types that may allow me to better utilize what I need. So say, for example, which devices use the most electricity? I actually just need to put this in Excel. I can say, show me this as a table. It's going to give me the same information and show me this as a table. I'm going to sort of the debugger so that we can sort of see this sort of tick up. So this, what you just saw is a component that is dynamically adapting based on the large language model's understanding of the library, in this case, recharts, that I'm using in order to make these calls.
So what you've had to do is, as part of your prompt, give the LLM information about the library that it's using. And you haven't given
That's
it
right.
any other information. You've just said, here's the library that I'm using. Here's a function that will call that, that will call that library with parameters. You need to give me the parameters.
Right.
And that function call is called generate simple chart by, looking at your, okay.
Right.
And that information that comes out, that JSON that it's sending back, you send directly to the library, question mark.
Yeah.
Okay.
Through the component, simple
Okay.
React or Angular component that's going to render this. Yeah.
Okay.
There are times where, like, you were very careful in stating that I was just providing the LLM context. And so this is essentially just a system prompt that, in addition to a doc string within a Python function, knows to, follow certain, structured outputs in a way that doesn't break what my visualization library recharts expects. And so you give it a couple examples and it will give you the same results consistently for the most part. But sometimes it gets it wrong. Go ahead, Alan.
And I think that's also useful to know is that you're, and I feel like I had this conversation with someone recently about agents in general, and maybe it was you, that, playing with agents, we're actually on rails. We have constraints that are still set, and we are making sure the LLM knows what those constraints are. So part of the
That's correct.
context is the constraints that it needs to run in. And we've made sure that those constraints are real constraints. So, this library is not going to take arbitrary code to execute.
That's right. And I want to just put a fine point on something you just said and actually make a slight distinction. Today, there are two types of, when people say agents, there are two types of things that they're talking about. They're talking about a completely autonomous system that reasons on its own and goes out and finds the right tools to do. That's not what I'm doing. I'm actually more, like you said, this is an agentic workflow. And by workflow, I mean that I'm guardrailing what outputs I need or what tools or resources I needed access to in order to reduce the level of non-determinism that these systems would take if it were to go on its.
Right. But, let's be honest here. I don't think anybody is really doing agents that are completely independent. They all have.
They claim.
No.
A lot of people are claiming they're doing that. So I just want to say.
Sure. A lot of people are claiming that. But when you start when you start drilling down into, what does that mean? You find out that they really have constrained tools. They just have a lot of constrained tools.
Right. I just took a course, to your point, I just took a course called Small Agents. By the way, you and I are, we should just say we're not experts at agents.
Nobody's an expert in agent.
Some claim they are. I'm just learning. I just took a Hugging Face course on it, and just to understand, just to apply my understanding of, in that case, small agents and LangChain and how LangGraph works. And I'm sort of applying it my own. Again, in my code, I'm not using any abstractions. This is just as simple as I can do it. Maybe someday in production, I may go to the LangGraphs of the world, and I will get the benefit of tracing rather than rolling my own. And so, I just want to say, some people claim that they're doing all of this magic, and we can talk about how I even
I,
with, yeah,
and I'll pick this fight another time. I'm not about to get
pick it another time.
right.
Yeah,
Let's
yep,
focus
yep.
on this.
Let's focus on this. So let's go ahead and rerun. I'm going to clear this again. I'm going to rerun one of I said, nah, instead, let's do a donut chart. Now I wonder whether, okay, so this is stateful, so it should be able to remember, maybe, because, okay. Oh, it did it for the mail item, which I've never done before.
Which was
I
the
don't
last
know.
one that okay.
Which was the last one that I did. So now I just took my mail items and tried to put it as a donut chart, which makes no sense. But I'll
No,
keep it.
it makes a lot of sense. I
Right.
mean,
Okay.
what it tells you is that, of your mail, 50% of it are
50% of letters, magazines. That's actually useful.
That's interesting.
I've never seen this visualization before, but that's the power of generative UI. Now, I was talking to you or someone about this, and one of the use cases that folks come to me and talk about is accessibility, or even A/B testing, right? And so, say I needed warmer colors, or let's say I needed to have the LLM reason a little bit deeper to generate accessibility compliant or just high contrast colors.
Mm-hmm.
It should theoretically be able to do this for me in the way that the system has been designed. So if I were to say, make this, and by the way, in a real use case, I'm not going to get on another rant about chatbots, but in a real use case, these would be UI elements that, again, that you tested, that pass your users' expectations and what they're used to. So there's no cognitive load of this sort of having to sort of type in exactly what they want.
Let's get to that in a second. Okay, so
yeah, I would completely remove this. So let's make this visual a high contrast chart. Now, technically, what's happening now is the visualization. Again, this is just Gemini. It's supposed to just basically do the same thing it's been doing, just dig into the library documentations, which it has as an embedding as part of our vector store, and basically do magic with it. But it's not working. And so this is sort of just a lead into what we wanted to talk about in this episode.
Okay. So before we get there, I've got a question. You said ideally what you would do instead of having a chatbot is that you would have a button that you tested and well configured.
Right.
Okay. Now, is
a
that
button, an element, a
right.
visual component of some sort that, in my opinion, for a constrained use case, not google.com or not wikipedia.com, where people are used to searching. There's a reason why I have these chips with shortcuts here, but go ahead and ask the question.
But to me, that says, okay, so if we have a constrained environment and we've got constrained buttons and we have done this and tested it, we don't need the generative UI. Because we can now go in and predefine ourselves what that needs to be.
You actually do need, you're treading on something here. The components that then render on a screen over time is custom tailored to me getting to my goal faster.
So basically you're saying you need to use the LLM still, because it's still the one that is generating the dynamic result.
Right.
I would kind of argue, but okay, let's throw out the dynamic result. If we're working in a constrained environment, we can constrain things. Now, I think the where it might get interesting is if we essentially have both. We have these suggestion chips, and this is again a concept we learned back in the Alexa and Google Home era. Let's have the suggestion chips. That's fine, but let's also take that dynamic input
Right.
so
Because
that
we
so
don't
that if
know.
right.
Yeah,
So, and if we see that a user is saying something or a variant of something frequently, that becomes a chip.
that becomes a chip. Right. Right. Yeah, again, I think maybe I may have misspoke, or I did a terrible
Well,
job explaining that. Yeah. I think
I
we're on the same page.
I think we
100%.
are. I think my concern is, you know, I guess what it is I don't want people who all they're ever going to do is build a constrained input
Mhm.
to be using to be spending cycles on LLMs, because you don't need that. If all you're going to do is limit these types of charts, these types of inputs, these types of colors, we know how to make menus that do that.
That's right. That's fair. What I'm saying though, if my objective as a business or as a product is to fast track my user to done, what can I do to eliminate a step?
Yeah. Yep.
Right. So yeah.
And I think it's also, if I am making data available, you talk about this in dashboards, that's common in business room, where you're putting slides up on the screen and the CEO in the front row says, yeah, what was that number for the fourth quarter? And you're like, dear.
Right. And this is where, like, in another use case that I've gotten a lot is, as somebody made mention, I was doing a workshop over the weekend and said, it was last week, and said, oh, maybe this can tie into our RAG system. I go, baby steps, guys. let's crawl first, maybe walk, stumble with our hands out. All right. So
So
in
so so the issue okay, so now going back to the problem, which is when we give it something that it should know about, but doesn't, how do we make sure it can handle that in the future?
I'm going to give it something that I know for sure the LLM is not going to go. It's definitely going to croak. This page renders in real time. And so if it takes a couple seconds, I know it's going to croak. So in order to solve this, we fine tune. So first, let's define what fine tuning is.
Okay.
But and Google or IBM, funny enough,
Love the
has
picture.
I love the picture of glass here. But anyway, fine tuning, according to IBM, in machine learning is a process of adapting a pre-trained model for specific tasks or use cases. It has become fundamental in deep learning. It's a technique that is part of the training process of foundation models. If you are an old school recommendation systems person or a old school machine learning system, you probably remember transfer learning. That's essentially what, I guess, fine tuning is a type of transfer learning or is a subset of transfer learning. So that's fine tuning. Why am I fine tuning? Or why am I considering fine tuning? It's not to teach my model that I'm pending on what a whisker plot is or what a high contrast visualization is. It is to teach the model new patterns,
Mm.
as Google, as IBM is saying here, specific tasks or use cases. That's important
So
because
the
you're not
way
teaching it new knowledge. You are teaching it a better understanding of your domain specific needs, like how D3 library renders a high contrast visualization.
the way
According
I like to think about it and the way I try to explain it to people is it doesn't teach a new knowledge. And that's important to remind people and to understand. We have other techniques for that. But what it does do is teach new vocabulary. It teaches new words. It teaches new patterns. Because remember, these are just pattern systems.
Right.
But I feel like the big deal about it, the fine tuning part, the tuning part of the fine tuning, is that we are working from a foundation model, which is why they
That's
were
right.
called foundation models originally.
Right. The base model of
Right.
sorts. Yeah.
Is that,
Yeah.
we're able to take something that has already been trained on a ton of material that has a lot of basic um, language structure and basic patterns already built into it. And we are giving it some additional patterns that meet our needs a little bit better.
Correct. So, if you are all familiar with supervised learning from predictive AI day, you know the most important step in creating a model, a machine learning model, is to give it data. Example, these are dog, and give it a
Right.
lot of them.
Okay.
With supervised fine tuning, essentially, we're doing the same thing. We need to do a data prep, right? So we need to collect queries, a lot of them, and map them to a shad CN UI, recharge D3 or tremor, which is what I'm using right now. I'm gonna share an example of that training data. So here, where it says sample training data, you have one of my JSON objects with your instruction. This is your instruction to the model. The input, which is an example of a user query, and then the desired output based on the parameters or properties rather of the library that you're using. And you provide this with an order of magnitude more of these. So 500 examples. But the point is I'm giving it JSON data with query components, parameters, some context, and then I'm augmenting that data using logs. It's a combination of synthetic data and Stack Overflow, or even examples that I've created myself, mostly because I don't advise folks to over-index on having Gemini or ChatGPT just take this example and then create me 100 examples, because then how do you know you have enough variety,
Yep.
diversity of it? Yeah.
So, and that kind of gets to what I was going to ask, and that's, given this training data and given 100 samples of similar training data, how well do the models kind of generalize it? So in this case, as a human, I might fixate on the saying, okay, you're saying energy usage, and that means that, my component needs to be energy heat map. And, we talked about time of day, and that means, the x-axis needs to be time of day, the y-axis needs, as a human, I'm picking out parts of that. Does the LLM sufficiently generalize this structure?
Surprisingly well.
Okay.
Now, this starts, I have to be brutally honest, starts bumping up against the limits of my understanding as to why.
To be honest, I think it bumps up against everyone's understandings of why.
Okay.
As I understand it, this worked out surprisingly better than most people thought it would.
I've talked around just throwing the word model, right? I'm actually using the Google's new open weight model called Gemma 3, right?
Okay.
And Gemma 3 is, I'm guessing distilled from one of the Gemini models. We don't know. It's not, but we're glad that it's an open source model or open weight model that we can all have access to. What is actually happening here with this model is a couple things. One, I'm setting training parameters. So basically your hyperparameters from old school machine learning. So my learning rate, the batch size, how many epochs, like how many times do I want to back propagate to basically teach it and
So,
capture. Yeah.
so can you explain a little bit about what some of these parameters are? Because I feel like this is kind of the key to understanding fine tuning.
Learning rate controls the step size at each iteration while updating the model's weights during training. It determines how quickly or slowly the model learns. Okay. So it's the rate of learning, essentially.
So and that's in turn that's measured by steps.
Correct.
Okay. So it's so
Every step size, yeah, at each iteration. So,
so why would we adjust that up or down? It seems like we wanted to learn quickly, right?
no, because you're always the whole point of the hyperparameter is you've got a bunch of knobs, learning weight being one of them. If you tune it up, you may get a result that doesn't really further your performance gains that you want, or it may actually return worse results. In our case, we may notice that it is not learning as quickly
If
as
even
we have, and so it'd be more expensive to keep training, for
okay.
example.
So the
So
learning rate does impact how much resources are used in every iteration.
let me restate what I just said, and then maybe we can get to it. I thought I had notes, but I don't. So I'm gonna try to remember how I do this. The best way I can explain this is that a learning rate can cause like if it's too high, it can cause the model to overshoot the optimal weight. So again,
Ah,
what we're trying to do here, because we don't have access to the entire model, we just want to just take the um my words are eluding me right now. Anyway,
the essence of it, the okay.
yeah. If it's too low, training gets more expensive because training becomes slow. That's learning rate.
So if it goes too fast, we essentially overtrain it and it ends up overfitting things.
Overfits. Yeah, exactly.
So we get things that match our pattern exactly, but not near our pattern
Mhm,
terribly well.
mhm.
Whereas if we underfit it, it's the exact if our training rate's too low, it's the exact opposite. Okay.
And then there's batch size here. Is there batch size? I don't have batch size. I do have batch size. I can't see. I do. I see training epochs is the same as any machine learning model.
Well, so
Uh-huh.
what's a training epoch for people that aren't familiar with
Okay.
it?
So what it means one complete pass through of the entire training data set.
Okay.
So essentially the number of epochs determine how many times a model sees the entire data set, right?
Huh. Okay.
During it's propagated, it's back propagated. Like how many times does it see? So let me
And I guess I can see this as important because it's basically reinforcing the pattern after each full round. Does that
yeah. So you actually mentioned something earlier that matters with training epochs as well. So you mentioned overfitting, right?
okay?
In hyperparameter tuning, which is the most, it's like it's like incantations, in my opinion. Maybe a data scientist in your audience can tell me I really don't know what I'm talking about. To me, it's just like this fairy dust where the more epochs you set can lead to better learning, but it can also cause overfitting. If the model learns the training data way too well, it's like almost is like captures it in memory, and then before you know it, it's spitting out entire Taylor Swift or literally, I don't know what license recharts I have, but I think I checked all my licenses. I just don't want to have it regurgitate entire things that might be proprietary. So
Well,
training epics go there. Yeah.
I mean, I think more importantly, you don't want to regurgitating something when it's not the right thing to regurgitate.
Right. Because again, to your earlier point that you were making, that in some cases you don't want to constrain too much, right? That's the point
Right.
of an LLM, because every use case is going to be slightly different. And so if I'm being too constrained, that leads to more problems. But we have spent a lot of time. We could keep going on. There's low rank adaptation. There's a whole bunch of other parameters that we can talk about. The point I was trying to make, though, here is that in order to fine tune a model, I want to basically demystify supervised fine tuning as this special thing that only the large labs do. That if it matters to your business or your product, you too can ship a fine tune of something that is domain specific to you, not to help it hallucinate less, because it won't, not to help it learn new knowledge, because as you mentioned, doesn't, but to actually better have it understand the structure of your data, the schema, or the tasks that you care about.
I was going to say, and at the same time, better understand what we are asking and how that maps to the structures that we want.
Beautiful. So that's fine tune, right? So I think over here I just looked at Google and we defined it as well. I think another thing that I get a lot is like, how can I afford fine tuning? It's very, very expensive. In my case, I don't even have that much data. I'm using Colab Notebook, paid version of it. I'm using libraries from Hugging Face, Transformers library. I'm using Bits and Bytes. Can't remember what Bits and Bytes is. It's part of Flow. PEF, which is something efficient fine tuning.
Performance efficient fine tuning?
Maybe. I
don't always remember either. Yeah.
Yeah. Anyway, so that's fine tuning essentially. We are setting our training parameters as we've gone through. We're using, there are many tools for this. I use something called TRL just because I love a callback to the 80s and MTV. But this is Hugging Face's, it's like a trainer library called TRL.
Okay.
And it's specifically for fine tuning. We have our model, our Gemma 3 model that has performed very well. As of recording this, I'm still in the process of getting this done. That's why the system is breaking. Maybe one day in the future, I can come back on the show and show you the final product.
Well,
and
I
then
think
monitoring.
I think one of the important points that goes with this as well, though, is that, and this is the point that I just talked over, is monitoring.
Yeah.
Is that, for any of these systems, we do need to see how people are using it. And if we see they are stumbling into areas that are producing negative results, great, we just got more training data or more testing data that we need to include in the next round of fine tuning.
Right. Monitoring is a huge piece, but before we even get to, monitoring it, we need to save the model. I'm going to be using Hugging Face to sort of host the model, so we can, just like a commit with Git, you would sort of submit that. You need to save the model as well. So we want to save and merge my fine tune as something called, like, back in the day, it used to be a pickle format, but now that's not secure. So we use something called safe tensors. Now, to host it as an endpoint, there are many ways to do it. I'll probably go with Google Cloud Run and just have like a fast API just containerized as part of that,
That's an
serving that. Yeah.
that's a great, so, you know, the more I see about that, the more I like it, is using Google Cloud Run with GPUs.
Yeah.
This way it scales to 0 when nobody
Yeah.
wants it. You can scale it up when you need to. They give you, you know, there is an image available that has Olama on it,
Yeah.
so that you can launch this inside Olama. It gives you the endpoint. Magic happens.
Yeah. And
Go,
alternative to
going
that.
back to our Clarke versus Niven,
That's
magic
right.
happens.
Magic happens. Yeah, Cloud Run is the way to go. I found the alternative is probably spinning up a Vertex AI instance or Bedrock if you're an Amazon person or whatever the equivalent is on Azure. But note that what you just said, Alan, you don't get the luxury of. Though Vertex may scale you down, it may not scale you all the way down to 0. There may be some resources.
Yeah, it doesn't scale. They don't scale to 0. It's been frustrating to me as I've been going into this. And this is something I actually demonstrated way back when we looked at Gemma 1, was you end up spinning up an instance. And that seems, I mean, you know, there are probably circumstances where it makes sense.
Oh yeah, high traffic could be
right. But
Yeah,
I feel like even in a lot of high traffic situations, you're going to have traffic fluctuation. And it's, you know, for a lot of cases, using something that can scale up and down seems like a much better result.
Right. Yeah. So before you get to monitoring, you have to host it somehow. And so that's great. Great that you've gone through the pain of that. So I know who to come to with that part. I'm not joking. I know a lot of things. I suck at that kind of stuff. So,
and you know what, this is it's an interesting point, and this is a little bit off topic. I think we wanted to talk about today, but it's an interesting point that, you know, at some point we can cook up all these models that we want, but at some point you need to host them. You need to use them somehow.
That's how they're useful. We've had this conversation before. One of my first appearances on this. And then we have to integrate it. Now you've got your endpoint. So what we do with our endpoint, we need to, integrate it with our code. In my case, I just use like a conditional solution. Again, I tend to roll my own rather than use abstractions like custom llama index or LangChain type libraries. I'll learn if I ever become, if there's a lot of demand for anything that I'm working on, that might change. But now it's just a conditional, like, a fallback model, just like a Gemini 2.5 model is everything fails. But you just have it use my custom model if it doesn't. And then,
and I think one of the great things though is we can even abstract that completely away.
Right.
You know, your code itself doesn't care about what's delivering it.
Right. Yeah.
You know, so you can do things like, you know, if you were offering this as a premium service, my premium customers will get access to the high quality one, and my not so premium ones will get access to the one that, you know, isn't trained quite as much and may run a little bit slower. But, you know, or, you know, one that has lots of additional fallbacks. You know, that's when you've abstracted that away, when you've made that an API, that starts making things kind of powerful. But that's old school software engineering.
And that does not, that's a very important point. That does not change. That does not change. There's a lot of times we look at AI as this special snowflake thing. At the end of the day, it's being used, it's being consumed by software. And as if I were to put on my product, I say the model is not the product, right? It's just a vessel to get your users what they need seamlessly or whatever the objective function is, right? So yeah, then and only then do we get to monitoring.
So observability and monitoring, I think we're going to have to take up another time. We're going to have you back, Noble, on Two Voice Devs.
Two Voice Devs. This was fun. Thanks, Alan.
Thanks, Noble. You take care.